Hi, it's Mr. Blystone here. Welcome to the first lesson of the first unit of Algebra 2, the language of algebra. So first, let's start off with a few definitions, kind of review definitions you probably remember from earlier courses, but here are some definitions that you might want to write down. So a variable is a symbol that can be replaced by any member of a set or of numbers or other objects. An algebraic expression, or just an expression, is a combination of numbers and variables using the operations of arithmetic. Remember the operations of arithmetic in case you've not really heard those words. Some people don't use arithmetic, the word anymore. It's just plus, minus, multiply, and divide. That's just arithmetic. And an algebraic sentence is an expression related with a verb. So you might want to pause the video, write these definitions down. But we'll move on. Let's look at some verbs in algebra. So these are some mathematical verbs we have: is equal to, not equal to, less than or equal to, approximately equal to, greater than or equal to. Most of these you've seen a lot. Probably two you don't see too much is not equal to and approximately equal to. Approximately equal to is very rarely used. I mean, you use it when something's rounded off. It's more of a you're saying about, but it's not used too much. Not equal to is usually used when we're restricting something. So, like if we have something divided by a number and we want to make sure that we say that whatever makes the denominator 0, it's not equal to that. That's when we'd use it, but we don't use it too often. All right, so algebra is a study of expressions, sentences, and other relations involving variables. That's algebra. So let's look at an example and see what we can do. So express the cost of Y cans of orange juice at X cents per can. So let's think about this. If we didn't know immediately what we were supposed to do, what could we do? Well, we could say that let's just give it a price. Let's give orange juice the price of 10 cents per can. Okay? 10 cents per can. So if I buy 5 cans at 10 cents per can, well, let's see here. To figure that out, I know I'd multiply. So let's say I'd multiply. And if we multiply, cans cancels out with cans. 5 times 10 is 50, and that's 50 cents. So we know, therefore, that we're multiplying. So if we take now and say, okay, let's use the variables. Y cans of orange juice, Y cans, times, we'll use a dot here, X cents per can. Or we could say Y X, or we could say X Y. Either one of those would work. Either one works. So that's how you do that. So now I want you to try. It says at North High School, the faculty F increased by T teachers. How many teachers are now in the faculty? Pause the video. See if you can figure this one out. All right, I'm sure you've come back. You've tried this. So we have the faculty. The faculty is F. It increased. So increase is added. So it increased plus. And how many did it increase by? T. So F plus T. That's it. F plus T. That's how many teachers are now on the faculty. If you're not sure, if you're like, is this right? Well, say the faculty had 30 teachers and they gained 10 teachers. So that's 30 is F. 10 is the number of new teachers, T. So it's F plus T. So we're sure of that. All right, another example. It says Kim collects stamps. She now has 9,000 stamps. If Kim buys 40 stamps each month, how many stamps will she have after M months? All right, well, we have a variable, M. M is equal to months. So we know, and so we need another variable. We need stamps. So let's call stamps S, since it's the first letter in stamps. All right, she now has 9,000 stamps. So we start off with 9,000. And it increases. 40 times M. 40 times the number of months. Every month she adds 40 times the number of each month. So if it's 2 months, it's 80 more stamps. 3 months, 120. And we could even write as a whole equation that equals S, the total number of stamps. So you could write it without that, plus equals S. You could just write this. That's fine. Or you could write it as a whole equation like that. Either or, good way to do it. All right, so now you. It says Luis has 20 sticks of gum. He gives one to each of C friends. How many sticks of gum does he have left? So pause the video, see if you can work this one out. All right, so again, this is much similar to the last one. So 20 sticks of gum. He gives one, so they're going to decrease one to each of C friends. So it's however many friends he has is C, however many sticks of gum he gives. So that's just C. 20 minus C. So if he has 20 friends, he doesn't have any gum for himself. If he has 5 friends, he has 15 sticks of gum left. If he has 21 friends, someone doesn't get gum. So there you go. Pretty simple, pretty easy. 20 minus C is your answer. All right. A few more vocabularies for you. Evaluating an expression. That's just substituting for the variables in an expression and calculating results. Plugging in, as some would say, plugging and chugging. An equation is a sentence stating that two expressions are equal. So with those verbs, if it uses the equal sign, it's an equation. And a formula is an equation stating that a single variable is equal to an expression with one or more, that should be one or more, one or more different variables on the other side. I'm going to pause the video and write out these definitions. All right, so here are some examples of formulas, some that you've seen before. How about circumference of a circle? Well, circumference equals 2 pi times your radius, r. You've probably also seen area of a circle. Area equals pi r squared. You might have seen other formulas like, for an example, volume of a cube or of a prism equals length times width times height. These are all formulas. These are all examples of formulas. Even something like you may have seen years ago, in Algebra 1, this famous formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. The quadratic formula. Those are all formulas. So let's take a look at something else, some order of operations. Again, you probably remember these. So to perform operations with parentheses, brackets, or other grouping symbols like square root symbols or fraction bars, from the inner set of symbols to the outer set. Inside grouping symbols, use the order given in rules 2, 3, and 4. So basically, we start with things that are grouped together. And we go from the inner group to the outer group. So we usually call this parentheses. Take powers. Well, we can also call that exponents. Multiply and divide in order from left to right. M, D, and then add and subtract in order from left to right. Now, a lot of people hate this part, MDAS, especially in the US, where this is how we do it, as absolute. Remember this point. In order from left to right, multiplication and division, and addition and subtraction are on the same tier. They're on the same level. So if you have multiplication before division, you do it that way. But if you have a division before a multiplication, you do the division first. Doesn't matter that we say multiplication and division. It just matters that you do them in order from left to right, whichever one of those two you see first. So if you have both, you do the first one you see. Same with addition and subtraction. You do the first one you see. Now, if you're not in the US, you may know this as different. You may know this as B, brackets, O, orders, instead of exponents. And then they switch division, multiplication, addition, subtraction. Same thing. And again, if you're from there, again, division, multiplication. You do it in the order from left to right, it shows up. So if you have both, doesn't matter that it says in North America MD, in everywhere else DM, doesn't matter. Whichever one of those two comes first in the thing you're evaluating, you do that first. Just a little note on order of operations. It's a lot. You see these problems on Facebook, TikTok, and YouTube. I bet you can't get this, or a lot of adults, because they don't quite get this. This is very important to understand. When you understand order of operations, it makes it so simple. All right. Here's another example using a formula. It says the formula of d equals 1/2 gt squared tells how to find d, the distance an object has fallen during time t when it is dropped in free fall near the Earth's surface. The variable g represents the acceleration due to gravity. Near the Earth's surface, g equals 9.8 meters per second squared. About how far will a rock fall in 5 seconds if it's dropped near the Earth's surface? All right, so we need to figure this out. So let's make a plan. Let's see what we know. We know that g is equal to 9.8. We know that t time, we're wanting 5 seconds. Let's put units just so we know. And I'm just going to put s for seconds, s squared, and t is 5s. Okay, so now we can evaluate. So let's do just that. So our equation is d equals 1/2 gt squared. So we plug in. D equals 1/2 times 9.8. And let's go ahead and put the units. Meters per second squared times 5 seconds squared. Okay, so according to our order of operations, we do this part first. We square 5 seconds. So let's keep going. Let's do this the right way. So we keep our d. D, distance, equals 1/2 of 9.8 meters per second squared. 5 seconds squared is 25. And seconds is squared now since we squared it. 5 seconds times 5 seconds is 25 seconds squared. Now we multiply. So, just because of units, I think this is easier to do. So, but doing this, let's do this the fair way. So it says 1/2 times 9.8 meters per second squared times 25 square seconds. So let's multiply 1/2 times 9.8. Now, some people are going to say, but you put those in parentheses. The parentheses are just to separate. It's not to group them together. It's just to separate things, just so we know what is what. I could take them out, but this is not in for order of operations. But remember what they call the commutative property, or associative. Well, both. Commutative property says we can multiply things in any order. Associative says that we can group things in any way. We could group 1/2 and 9.8 and do it first, and then multiply by 25. We could group 9.8 and 25 and multiply them, and then multiply by half. We could group 1/2 and 25 and then multiply those together and multiply that by 9.8. We get the same thing. But let's just do it as we see it, just to follow the order of operations. So D equals, well, 1/2 times 9.8. Well, I know half of 9 is 4.5. I know half of 0.8 is 0.4. 4.5 and 0.4 is 4.9. So 4.9 meters per second squared. Units didn't change since that 1/2 didn't have a unit. Times 25 seconds squared. All right, units cancel out. We have second squared on the bottom. That cancels because we have second squared over 1. We could just say 1. So we're left with 4.9 times 25. So if you have a calculator, you'd use a calculator. Right now would be a good calculator time. 4.9 times 25. And you would get 122.5 seconds. Or rather, meters, sorry. I made a mistake there. I was thinking we got rid of the seconds. It should be meters. 122, not 1122, mind you. Again, that was I noticed that it's 122.5 meters. I think I was trying to box it in there and boxed it later. So 122.5 meters. All right. So that's how far that rock would fall in free fall in 5 seconds. Okay, now an example for you to try yourself. Let me move it up, sorry. It says, for a polygon with insides, the sum of the measures of the polygon's interior angles, t, is given by the formula t equals 180 times n minus 2. Find the value of t for an octagon. Pause the video and see if you can do this problem, and then when you come back, you'll see if you get the answer correct. All right, I hope you've worked the problem. Let me show you how to do it. So, again, we know that t equals 180 times n minus 2. Well, n in this case, octagon, means 8. If you didn't remember, that's 8 sides. So n is equal to 8. So 8 minus 2. All right, in this case, we have parentheses. So let me make this parentheses bigger so it doesn't look like an 18 or anything, so we know. All right, 8 minus 2 is 6. So t equals 180 times 6. Again, this would be a good time to use your calculator. 180 times 6 is, so t equals 1080. Now, sum of the measures degrees. There you go. Pretty simple. All right, so that ends it for this lesson. If you're following along and wanting to try some problems and you have the book, I would suggest doing 3, 4, and then numbers 10 through 32. All right, that about wraps it up. Have a wonderful day and keep learning.